nature, right? We human beings are not synthesizing red cabbage in the lab. It is naturally formed. And now we have got this red cabbage juice just by squeezing it or in a mixie, in a grinder, or by putting hot water in the red cabbage leaves and then mixing into it. Okay, so I am going to put little bit of this. Oh, why is it? Is it the natural color?
Yeah.
Okay. So this is little bit purple actually. Yeah, I told you it depends on how much anthocyanin molecule is there, right? So this anthocyanin, these molecules are found in red cabbage, in cherry, in blackberry, in grape. So depending on that, let me put it here a little bit. Okay. So this is the natural indicator that you have. And this can tell which solution is acidic, which solution is basic, because we have done the experiments earlier and we know when acid comes in contact with this anthocyanin water, they will turn pink red. When the base solution will come in contact, they will turn into bluish green. Now how much red that solution will become? Students, are you paying attention here? Hello? You are understanding everything what I am talking about? Yes? Yes, yes? No, no? What? Don't draw something. Please pay attention here. Now how much greenish blue or how much red it will become, it depends on the strength of the acid. If I have a light acid, mildly dilute acid, maybe it is not going to turn red so much. But strong acid, it will become very red. That is our expectation. Is it not? Okay, so that's enough. Now, that's the magical part. We know the theory. Other researchers have done the experiments. Now let us try that. Okay, we have lemon juice right here. What is this? Acidic or basic? Acidic. So if we add it to our red cabbage solution, what it is supposed to be? Red or pink or green or blue?
Red.
Okay, let me check that. 1, 2, science. Okay, you can stand up. You all can stand up if you want. You can come closer. Okay. All right. Let us see. Oh my God, that's happening. Science works, right? Science is always working. See? So, all right. As you can see, let me add a little bit more. Will it become more red? Yes, it is producing red. Okay.
It looks like pink.
So, in presence of this acid, these anthocyanin molecules which are dissolved in water, okay, they are showing this behavior. And once again, what is the secret behind different colors? That white light, sunlight, that is falling on this substance and they are getting absorbed and re-emitted by the molecules of the substance in here. And in this case, only those frequencies are re-emitted which are creating the sensation in our eyes as red. Getting my point? Okay. Why is your hoodie blue? Can you please explain me why it is blue color, not red, not green? I just told you at the beginning. Who can tell? What is the explanation? Yeah, please tell.
The sun is reflecting off of his hoodie and it's scattering molecules.
Yeah, close. It is just white light. It can be sunlight. It can be your like light from the room, right? It's white light means it's a mixture of all components. Like we have spoken about Vibgeo, different colors: violet, blue, red, yellow, green. So all those light, that light is falling on this material. Okay. Now the molecules in his hoodie, they are absorbing all those light and they are re-emitting, but only those frequencies are emitted which creates a sensation in our eyes as blue. So violet component might be scattered more, but our eyes are not sensitive to violet light. I explained in the very first class why the sky is blue accordingly. But all right, now you know why it is red. Now let us use the baking soda. This is the baking soda. Okay. If I add little baking soda here, what I expect? It is bluish green or red? See, is it turning color? Bluish. I told you bluish green. See, this is purple. This is like violet color. This is bluish, isn't it?
Yeah.
Good. So that works. So that is how science is working forever, right? when researchers have done experiments and they have found out the results, and lot of other researchers have done the similar experiments at the similar conditions and they have found the same result, they will say, yes, that is the law, that will happen, right? That is how you do science. It should be reproducible. If you do an experiment and say, hey, that is what I am finding out, then your friend does the same experiment at the same condition but cannot get the result, you will say, there is something wrong either in my experiment or in your experiment. But when lot of researchers are doing the experiments in identical conditions and getting the same result, you will say, yeah, that is happening because there is certain laws, rules behind this phenomena, and then you discover that law, right? Anyway, so what else we have? What is that? No, let us put this vinegar. What is vinegar? Is it acidic or basic?
Acidic.
Okay, so suppose I don't know, it might happen, I don't know, suppose the level is not there, but I know at least it is acidic or basic. I can try to put it here. Ah, that is acidic, isn't it? That is great. Now in the pH scale, acid means that pH level is 1 means very acidic, 2 less acidic, 3. So you have a scale of 1 to 14. That this pH scale that actually measures the strength of hydrogen ions. I told you, if we have acid in water, they will give H plus, right? H plus is basically proton. You don't have to worry so much about what is proton, what is H plus, that's fine. But H plus ions are there. So this pH scale that is measuring the strength of H plus ions in the solution. When it is very strong acid, that pH level will be 1. And very strong base, the pH level will be 14. Water, is it acidic or basic? Neutral. I mean, we can have acidic water, we can have basic water, but that's not the normal water. I'm talking about normal water. That is neutral. Its pH level is very close to 7. Okay. So if I add little bit water here, should I expect any change in the color? No, right? Let me add little bit water, and as expected, no change. But suppose, very simply put, some people have this lemon water. Okay, oh, this is just lemon in the water, so this is no more the normal water, right? And I don't know, because by looking at this, sometimes you might not be able to distinguish, right? But it's okay. Let me check whether it is acidic or basic. Oh my God, that's acidic. Okay, so what we said at the beginning, that these red cabbage solution, the extract that you get from the red cabbage, that is a natural indicator whether one substance is acidic or basic. Okay, and we can do that test very easily. What is happening here? Of course, chemical reaction is happening. The anthocyanin molecule that is dissolved in the water, when they are interacting with the acid, definitely those anthocyanin molecules are changing little bit. They are denatured, their original nature is changed. Similarly, when they interact with the base, they are denatured. But how that molecule looks like and how are they changed, that is little bit complicated. So since you are not familiar with these chemical expressions, we are not going to talk about those things. But I hope you are understanding the main point of our talk, right? Great, thank you. Please go back to your chairs.